Let's see. Customers who purchase these cameras also buy an extended warranty. given x equals 4 times p of x equals 4, and y is the set of all who purchase or purchasers. And binomial instead of and. Yeah, this problem is problem number 6, section 5.1. Sorry, can you hear me now? Yeah, so let's see. Let x denote the number of Canon. I can hear myself. What's up, man? Yeah, no, I'm right now I'm looking at my notes and I'm trying to figure it out. So I have the answer right here. And so these are the answers from the PDF document that I sent you. And I'm trying to set up the problem right now. Okay, so the Adobe file I sent, that's going to be, are you talking about the formula? Or are you talking about the answers I gave you? Because if you're talking about the answers I gave you, it's on page 178. And then I have a printed out copy of the formula sheet on hand right now, and I'm trying to look at it and trying to find the connection between it all. With just doing it myself, seeing the answer. And the professor, he told us just to do 6AB. And I know that this is a problem that he went over too. 60% of all customers who purchase these cameras also buy an extended warranty. So this would be a dependent, right? Since it's 60%. Let's see. I'm going to pull up Quizlet and see what the steps are. And maybe as I'm doing it via Quizlet, it will jog my memory on how to do this one. 5.1 is the section that I'm just doing right now. So this is question 6. So y given x, the number of purchaser x that buy an extended warranty has a binomial distribution. So this is the binomial. 60% of all customers who purchase these cameras also buy an extended warranty. Let x denote the number of purchasers during this week who buy an extended warranty. So we know that the probability of this is going to be 60%, which is 0.60, which is what I wrote. So the definition of binomial property is this somewhere in our notes? I'm seeing the formula right here. So given that it's a binomial distribution, I feel like I should just go back and look at the binomial questions. So it's saying right here that the probability of y equals k, where I guess k is some constant, is n is equal to n to the combination, which is k times p to the power of k times 1 minus p, which is q, because it's a complement, n minus k, which I guess that's the overall formula. I'm not sure if that should be written down. But then the combination, it's using in combinations, it's going to be the factorial n over k. I can also look at what the professor wrote on the board. Let me look at those notes, because I think he started it. Because we have to do it his way. Oh, he didn't go over 6? He went over question 1, question 9, and question 12. Okay, he said finish it on there. Jesus. I wonder if he actually does this. So this is k n minus k, which is the combinatrix, times p of k times q, which is 1p n minus k. This is in the formula sheet I send you. P of x is identified. I'm going to write it in a different color so we can see the difference. The formula is P of x is equal to the combination. Okay, that makes sense. That's how the combination is denoted, to P to the power of x times q, which is n minus x, where x is a given set, 1, 2, so on and so forth to n. So I can see the similarities to this of the formula that I'm seeing on Quizlet. Using that definition, we have p y equals 2 given x equals 4, which is what it's asking for. That's from the hint, right? Is equal to, so looking at the hint right here, 4 is n, and 2, which is y, is k. So the formula, when you're trying to find the binomial, given this hint right here, y is going to be acting as the n, and 4 is going to be acting as the k. Yeah, so this is going to be the f, and let me know if you're going over it too. And if you have another problem you want me to go over, I can go over it, because everything other than 5.1 I know mad decently. 4 minus 2 factorial times 0.60, which is the probability, right? So that's the probability. Also by the extended warranty, right? So that's the probability of y that purchase a warranty. Sometimes it's best not to understand it. I've been actually solving a lot of the problems without trying to understand the deeper, just learning how to plug it in. So then 1 minus 0.60, which is q, where it's 4 minus 2. And that's where the similarities are, because 4 is n, k is 2. So I'm going to plug this into my calculator. And I can share the screen of my calculator too if you want me to. Okay, so we need to know 3.4 through 5.1. Okay, that sounds good. So for this one, I can probably share my calculator screen. I guess I can't. HP prime. I guess not. I guess I'm gonna just plug it in my regular calculator. I just wanted to show you what I was plugging in. So given that n is 4 and k is 2, do you think he's gonna have us do the whole combination? Because I can do that too. I mean, the factorial 4, if we just focus on this portion right here, this is 4 factorial, 2 factorial, so then this ends up being 4 factorial over 2 factorial over 2 factorial, and then you get this, which turns into 3 times 4. Now you have the 2 factorial, which is 1 times 2, and 2 fits into 4 twice, so then you can get this part, so then it's 3 over 1. But that's not what I'm getting. If I plug it into the calculator, four factorial over 2 factorial times parentheses 4 minus 2 factorial, I get 6. What am I doing wrong here? Oh, because it's 3 times 2. I forgot to carry that off. So then that's 6. That's where little mistakes happen. So then that's 6 times 0.60, which 0.60 squared is equal to 36. 0.36 times 1 minus 0.6 to the power of 2. Oh, I'm working on A. So I have the answers right here. So this is the answer. And we're going to, I'm trying to get this one right here. 0.518. So I'm working on part A. So if you want me to look at the answer, I can look at the answer for you if you're working on the same thing with me. So this right here, 1 minus 0.6 is 0.4 squared is 0.16. So then this is 6 times 0.36 times 0.16 And then when we multiply 6 times 0.36 times 0.16, enter, we get approximately 0.3456, which that is not what I got. What is it doing differently? Am I forgetting a portion of it? No, that's what Quizlet's showing me. Ah, okay. I'm seeing what's going on. So using the definition with x equals n equals 4 and y equals k equals 2, you get the general multiplication rule. So this is the probability of y equals 2 given x equals 4. So we're going to use the general multiplication rule. So the general multiplication rule and we should have this in our notes, is that the probability of A and B, which is the general multiplication rule, that is going to be, I just want to make sure I'm saying this right. Yep, is the intersection. So this is the same thing as the probability of A intersecting B, which is equal to the probability of A given B times the probability of B so given that, which is also equal to the probability of B times the probability of A probability of A times the probability of B given A. So knowing that is the setup, we can find the similarity by using the probability of x equals 4, y equals 2. Right? So the general multiplication problem that we did right here is just the other side of it, because we're following the multiplication rule. See, they switch sides. B given A and then A given B. So this is equal to the probability of x equals to 4 times the probability of y equals 2 given x equals 4. Right? So then when we plug that in, and I'm going to refer back to the table so we're making the proper connections. So the probability x and 4, that's going to be 15. So that's where that 15 is coming from, 0.15 times the probability of y given 4, right? Which is what we solved right here. So in order for us, so this is what happens. We had to break down the problem. So given this whole formula for the multiplication rule, because I guess that's the joint probability, we have to solve this problem first, which is what we did right here. And now we're just bringing it back down. So then the probability of y given x4 is 0.3456. Now we multiply that together, and what we get is 0.15 times 0.3456. Plugging in my calculator, enter, and I get finally 0.05184, which is the final solution of the probability of x equals 4 and y equals 2. And if we go back to the answer sheet, that's in fact the answer, 0.518, and I got 0.5.184. So I'm going to duplicate this page so I can work on the other part of it. Copy, paste. All right. I'm going to hide this portion too because we don't need this right here. We can just look on the other sheet. Start another color. So B is calculating P of X equals to Y. So part B is going to be calculating, should probably just write it bigger. It's the probability of X equals Y. So the definition of the binomial property, right? So we already know that. And in our notes, right? So if you look at that Adobe sheet that I gave you, I should probably share the screen of the notes so you can see it. The come on, you piece of shit. with some of my windows. Finally, Jesus. Here it is. Let's hide this right here for now. Yeah, no. We have the tables. We have the tables. Yeah, no, I'm gonna print out all 8 tables for mine. Sorry, my computer was going really slow for some reason. Are you seeing it? Everything fine? I keep on getting like an error message. I know that YouTube was down earlier today. All right. So right here, this is the binomial formula that's on the sheet. And that's what we were using. So using that same formula, it's asking for calculate for when p equals x equals y. So for every time p equals x and y, we're going to have to find p of x equals y, given that x exists in integers on the set of 0. That's the logic, 0 to 4. See right here? So we're going to have to figure out for all of x times all of y, it's going to be a sum value. So we'll start off with the first one. The first one is p of y. No, it doesn't really matter. P of y equals 0 given x equals 0. And this is equal to 0 factorial over 0 factorial to 0 minus 0 factorial, right? Times the probability of 0.60, right? And that's the probability that who buy an extended warranty, and that's to 0. And then we're going to do times, right here it says q, but q is just the complement, right? Q is the complement of p, so we do 1 minus 0.60 with n minus x, 0 minus 0. This, right, when you calculate all of this, so when you do the combination, 5 combination, this factorial is 1 times, and then 0.6 to the power of 0, that's just 1 times, since you could solve this, but when you do 0.4 to the power of 0, that's also going to equal 1. So the total is just going to equal 1 right here. And then for the probability, again, right, y equals 1. So you're just literally plugging and chugging on this one, and you do the same thing. And I'm just gonna write the format that you have right here, just so it's just easier to write that combination, and then we'll just plug and chug from there. Oh, so you saw my exercise cheat? All right, sweet. But I think there's a delay. And I think I'm gonna write right here that in this formula, x is equal to n and y is equal to k, which is also equal to n, since they're both equal to each other in this problem. So given that, it's literally just putting 1 over 1. We're gonna be finding that combination times 0.6 to the power of 1 times the complement of p, which is I'm just gonna write 0.4 because we already know that by now. 0.4 to the power of 1 minus 1, which is just 0 again. And when you plug all this in, right, so the combination just plug it into your calculator, or actually write down the whole formula itself. This is equal to 1.6 times 0.6, and then this is equal to 1 because it's just to the power of 0. So that's always going to, since they're subtracting, it's always going to be 0. So it's always going to be 1. So then this 1 times 6 times 1 is equal to 0.6. Now for P of Y equals equals 2, given that X is equal to 2, is equal to the combination of 2n over 2k, which is 0.6 to the power of 2 times, and that power of 2 is because y is 2. So we're just using that same formula that we got from the original problem. And then that's going to be 0.4 to the power of 0, because it's going to cancel out 2 minus 2, right? But I'll put it down there. 2 minus 2. And then when we plug this in, right, for the combination, right? So that's a general rule. So when you're trying to find the combination where n and k, or n and x is equal to each other, it's going to always equal 1. So again, it's going to be 1. And so really at this point, you're just getting 0.6 to the power of 2, and that's going to be the answer, because this minus 2 minus 2 to is 0. So you're looking for the power of 0.4 to the power of 0. That's also going to equal 1. So really you're just solving this portion right here. All right, so that's going to be 0.6 to the power of 2. And that's going to equal 0.36. And I guess if you just keep on all the way to 4, right, knowing that when this is equal to this, you're really just finding 0.6 to the power of 3. Which is equal to 0.216, and this is for the probability of y equals 3 given x equals 3 equals the combination of 3 and 3, which equals to 1, times this, which is the complement 0.16 to 3 minus 3. And you're really, again, just solving for that. Now for the probability, this is the last part finally, for given x equals 4 is equal to the combination of 4 over 4 which is also equal to 1 minus 0.6 to 4 minus 4. Again, this is equal to 1, this is equal to 1, and we're really just solving for that one. And that is equal to 0.1296. Yeah, probably a huge delay. So, let me see this. What do you think? What do you think you do next after this? right? So given the multiplication rule, right, which is that same rule we saw right here, and we have it in our notes. I'll write it down. So the multiplication rule. Do that. Is the probability of A and B is equal to P of A times probability of B given A, which is also equal to the probability of B times the probability of A given B. So since we know that, now it's plug and chug again. So the probability of X equals 0 and Y equals 0 is equal to P of X equals 0 times P of X times P of Y, equals 0 given X equals 0. Right? So we know what all the probabilities for X are, right? And this is that little formula that we have in our notes. The P of X given the value of X, and it's, you know, that P of where X and Y. So given that value 0, 1, 2, 3, and 4, that's what we're given. So we get the values right here. So P of X times 0 is 0.1 times 0, which is equal to that's not right. Oh, they messed up. Times 1. All right. Oh my God, now I'm confused. This is the thing that sucks. What's the answer to this? Oh, I see where it fell. Okay. So this, I was looking at this one as if this was the one for 0, but it's right here. So you multiply. Now I'm back at it. So that was just the multiplication rule, but I'm going to do it the way the professor had it. With the way the professor would do it, we just break it down right here. P of x equals P of y is equal to the probability of 0, 0 plus P 1, 1 plus probability of 2, 2 plus the probability of 3 and 3 plus the probability of 4 and 4. So given that, we'll just plug those values in. I'm going to plug in all the values for x, which is 0.1, 0.1 times 1 plus, and just plug them all in right here. 0.2 and 0.6 plus 0.3 according to the table times 0.36 plus 0.25. So this is for, that's for that, that's for that, this is for this is for that. Let's do the multiplication because we're going to know we're going to have to multiply 0.25 and then 0.15 is going to be at the end. 0.25 times 0.216 plus 0.15, right? Yeah. Times 0.1296. Plug that into the calculator. 0.1 times 1 plus 0.2 times 0.6 plus 0.3 times 0.36 plus 0.25 times 0.216 plus 0.15 times 0.1296 equals 0.4014 approximately. What is the answer? And that is the correct answer. Jesus, the long ass answer. All right. So he just said for that one A and B, huh? So if that one's just A and B, what is the probability? And I'm gonna redo this one again, just so later on I'm gonna look back on that one. The next problem is 17. I have some other problems too if you want me to go through them. After this problem 17, I would have completed all of the homework. So we can go over the homework together, and I don't mind redoing it because a lot of the homework I'm very familiar with. So these are the answers that we're trying to get. And the question is, let's look at this question. Question 17. And what do we have to do? A and B. All right, this is always the hard part with the questions. I don't like this textbook. The people who do this, it's just not good. Okay, I can go back. I can go back to section 4. Which problem do you want me to go on chapter 4? Is there a particular question? Let's see. So what I noticed with 4 is just a lot of 4 is just plug and chug. But I need to know a problem. 4.6. Wait, we never did 4.6. I thought we just went to 4.4. Am I missing something? Or is that a typo? Oh, 67. Is that what you want? This one, the last one on 4? Okay, perfect. All right, so let's I'm gonna duplicate this and paste, and we can start on the top for this one. since it's all written out, I guess I may just work it again just in case. So it says, suppose that when a transistor of a certain type is subjected to an accelerated life test, and the lifetime X in weeks. So as soon as I heard that, I wrote this down. X equals lifetime in weeks, has a gamma distribution with a mean of 24 weeks and a standard deviation of 12 weeks, right? So I wrote that down. So it's giving you 2 right here. So we know what this the mean is, and we now know what the standard deviation is, right? And since, right, this is in the formula sheet, right? So if you go into the formulas, or even back, let me make sure I actually have this on my formula sheet. And this is for 4.4 gamma distribution. Yep, we do have it. So I have it in that Adobe sheet I gave you, and when you look right here, this is the formula for the corresponding mu and standard deviation for gamma distribution. So what I did is I isolated alpha, right? So I put alpha equals, just simple algebra, mean over beta. And the alpha mean, since we know mu, I brought in the 24 weeks right here, and we don't know beta, okay? And we don't know alpha. So given that, right, since we can use this, we can now have a common variable of beta. So then I set the standard deviation using this formula right here, right, to the square root of 24 over b. So I got this and I plugged it in right here, and this right here is the square root, right? So I did that. It's easier for combining like terms with exponent variables. Using this, I then broke it down, and I isolated the coefficient, and I pulled this out. So now I only have 24 square root, and since the beta was below, right, it's on the denominator, that's a negative square root, which it seems kind of confusing, but it's really just like even if you plug it into a calculator, right, 1 over beta, right, this is technically the same thing as beta to -1. So that's literally what it is. So knowing that, we're trying to find the square root. Now we have 2 like terms that we can combine. This is negative, this is positive. Now you only have a simple beta that's on a square root, and you solve for 24 square root, then you get 4.89. And then if you just ignore this portion right here, don't look at this. This is directly the next step, and then you want to isolate beta. So you divide 4.89 on both sides, right? So we know what the standard deviation is. The standard deviation is 12 weeks. So at this point, all right, I'm like, I already isolated beta, right? Now we just know that the square root of beta is equal to the standard deviation of this divided by the standard deviation 12 divided by 4.89. So you solve for that, right? And you get 2.45. But now we still have the square root of beta we have to solve. So we have to square both sides. So then you get beta equals 6, right? And then I just plugged and chugged into the calculator. So I'm pretty sure Professor Semyonov is going to want us to show, you know, like even if we plug it in right now, All right, now I'll turn on the math solver. Since we know that beta is 6, right? So to find alpha, we have to use this one, right? So we're going to plug in alpha is equal to 24 divided by beta, which we just found out is 6, and we know that that is 4. It's simple arithmetic. So that's how I got the alpha afterwards. So you're literally just citing all the variables to alpha. Since they have a common variables of alpha and beta, you're just isolating that. Simple. And then we go to the real question, right? So I wanted to solve for this before I move on. So what is the probability that a transistor will last between 12 and 24 weeks? So the probability, and I just, at this point with gamma distribution, I just automatically assume inclusive unless it explicitly says exclusive, or if it makes sense to have it just like less than. So it's saying, what's the probability that a transistor will last that will last between 12 and 24 weeks. So that means we're saying the probability that 12 is less than or equal to X and less than or equal to 24. And so this is just the 24, right? So this is B, this is A, and this is just B minus A, right? By doing that, by doing that subtraction, we can find where that little intersection part is. So the probability, and I like setting it up this way. I feel like it's very important to use the less than, right? Because a lot of the mathematical problems, if you look at it from here, this is the X and then the Y, and you're trying to solve for like any cumulative distribution, you're really just solving for everything that's going to be on the left side of X. So less than is how I like to set up the problem, because if we're solving for greater than, then we're going to be trying to solve for this side, and then that involves the complement. So I try to set up the probability to always be less than or equal to the variable that we're trying to find. So if you go back into your formula sheet, and let me verify that I have that on my formula sheet for gamma distribution. Yes, I do. And so the probability of any given cumulative distribution is going to be this function right here. So it's the same setup, right? But for this is 24, and then this is for 12. And then I plugged it in, 24 and 12, and using the, as you can see, the beta, here's the alpha, right? So now I'm plugging it in. This is perfect setup for the professor. And then you solve for this, and then you get 4. And then you solve for 12 over 6, and you get 2. Using this is when you go to your table, and if you want, you can pull out that table if you want, and that's going to be table A6. Let's see. So if you go in table A6 and you look at it, right? So this right here, that's going to be your X, and then this is going to be your alpha. So when you look at your table and you go down to 4, and you go to where 4 and 4 intersects, you get 0.567. And when you look at the table right here, you get 2 and 4. Oh, sorry, I did it backwards. For 2 and 4, you get 0.143. Then you subtract, and you get 0.24, which is the probability that 12 is less than or equal to X, which is less than or equal to 24. And if you go to the answer, that is the answer right there, 4.424. So that's the steps for this. So then part B, what is the probability that a transistor will last at most 24 weeks? Is a median of lifetime Yeah, so that's the first part. I like to break it up into certain parts. What is the probability that a transistor will last at most 24 weeks? And then it asks, is the median of the life distribution less than 24? Why or why not? So when we're trying to find the probability of x less than or equal to 24, right? Well, we're just in luck because it's right here. So whatever we solved for the probability of x less than 24 is, since we know alpha and we know beta, right? And I'll just show the step, even though it's right here, right? We know that beta is 6, and we know that alpha is 4. So given that the formula is, make this thicker, I like it thick. So knowing that this is f of x, and if we look at the formula, right, you go to the formula sheet, it's x over beta and alpha, right? So this is the same thing, 24 over beta, and then alpha is 4, and get that same thing just like we got right here, 4, 4, plug that in, you get this value solved in part A, right? And the mu, how did I get the mu? Oh, so the mu, right? So since this is the probability, right? It's literally technically on the 56, or if you round up, the 57th percentile. The mu, right? Sorry, the mu has to be equal to 0.50. So we know that the mu, the median, is in fact less than 24. And yep, it shows it right here. So it's same value, 0.567, where the median is less than 24. And that is right, because this is greater, right, than 0.5. Now part C is asking, what is the 99th percentile of the lifetime distribution? And I believe I did this correctly. Yeah, no, that's fine, man. I'm just gonna keep doing some other problems, and yeah, it is probably too slow. I would much rather prefer a meeting, you know, like a group chat, and then have you explain certain things. Like that's what I would do when I was at U of H. Me and my friends, we would meet up and just like do the problem on the whiteboard. So yeah, but the ETA is just using the table. Yeah, for this one, I just look back at the table, and I literally look for a value as soon as it reaches 0.99, right? And as soon as it reaches 0.99 is when alpha is equal to 4 and x is equal to 13. And since we know that x in the function f x alpha in the chart, right? Since we know that is equal to 10 according to the table, you just solve for that. We know that beta is 6, x over 6 equals 10, so on and so forth. See you, man. I'm gonna study and I'll be here.